This is section 3 of 6 on Thioguard. This section will deal with corrosion control, perhaps the most fiscally important aspect of Thioguard. Thioguard is a chemical strategy that can be used as a total system treatment. For those of you that have heard of Thioguard, it's the fastest growing odor, corrosion, and fog strategy in the U.S. today. Thioguard is milk of magnesia, industrial strength milk of magnesia, for municipal wastewater. The total system treatment concept grew out of the use of magnesium hydroxide for nitrification when it was found that when added to collection, it could permeate through the system and provide benefits at each step along the way. As a consequence, Thioguard controls odor, corrosion, and fog while improving treatment. This section will deal with its reduction of corrosion systemically. Today, major sewers are failing approximately 6 times faster than they can be rehabilitated. Standard operating practices must change, and without change, approximately 50% of our major sewers will be in poor, very poor, or even inoperable condition by the year 2016. In sewers, anaerobic bacteria can metabolize sulfate to hydrogen sulfide. Aging infrastructure is a misnomer. Most of the problems from sewer failures comes from acid attack. Thiobacillus oxidizes hydrogen sulfide to strong sulfuric acid, which attacks metal and concrete surfaces. Strong acid produced by this can reduce pHs to below 0. Non-corrodable materials are far more expensive to use, and these materials still don't address the issues of odor and fats, oils, and grease. The problem has become very widespread. The question, though, is why is it happening faster today than in years past? For example, in 1972, the Clean Water Act went into effect. These regulatory impacts have caused problems for wastewater managers across the United States. Reduction of metals corresponds to an increase in sulfide. So does reduction of phosphates and an increase in sulfonates. Pretreatment, low-flow plumbing fixtures, and tighter budgets all contribute to difficulties for managers in charge of POTWs. As an example, let's look at concrete with a sacrificial thickness of 2 inches. If the surface pH of the concrete is 4, its useful life will be somewhere in the range over 100 years. That same system, however, if the surface pH falls to just below 3, its useful life falls also to 20 years. At a surface pH of 2, its useful life is only 8 years before the rebar will be showing. Assessing the system can be simple and inexpensive. Measuring the surface pH of the infrastructure can provide useful information for managing your system. If the surface pH is 4 or higher, the useful life of the system is about 100 years or greater. If, however, that pH falls between 3 and 4, the useful life is 50 years or less, and if it falls to as low as 2 or lower, that useful life will be 8 years or less. A system map showing surface pHs and a graphic representation is a useful tool for managers. Each time confined space entry is done, it's recommended that surface pH be checked, recorded, and maintained. Thioguard solves a wide range of serious wastewater challenges. Its solution pH is 8.3, and its surface area is nearly an acre per gallon. At a solubility of 9 milligrams per liter, it provides buffer capacity that can be used systemically. It's safe and economic. Adding Thioguard to the collection system provides a source of alkalinity that permeates through the entire system. Along the way, this solves the problems of odor, corrosion, and fog. The same systemic treatment can be used inside the plant, but has most effect and is most economic when used outside the plant for odor, fog, and corrosion, as well as enhanced water treatment, solids quality, and air quality. Surface pH is a useful tool, and when Thioguard is initiated in the system, we often find that the surface pH, which is previously depressed, will increase. Within 6 months, the corrosion rate in this example fell by a factor of 10, and this is one of the worst cases. Thioguard reduces corrosion by increasing surface pH, but pH isn't necessarily the entire key to how Thioguard works. For the purposes of this presentation, however, corrosion is the focus. The agency can decrease their corrosion rates by more than 3,000% if surface pH is increased a mere 3 to 6. And in this example, you can increase by 250 times the useful life of the system as a consequence of corrosion. This has real value in real dollars. When surface pH falls below 4, the life cycle cost assumptions are no longer valid. Odor control, elimination of fog, and improved treatment are values to agencies, and further benefits can be discussed in the videos that follow. But the difference in annual pipe replacement cost between a surface pH of 4 and 2 is 1,250%. As an example, amortized capital costs for major sewers are estimated to be over $100,000 per mile per year. Thioguard extends the useful life while eliminating odors, sanitary sewer overflows, and it saves money by extending the life of that system. As an example, we take a 30 million gallon per day system. The agency switched from using calcium nitrate to Thioguard, and the surface pH in a 6-month period increased from 2 to 5. The avoided corrosion costs alone were over $4 million. The cost of the Thioguard resulted in annual savings of over $3.3 million for this 30 million gallon system. Surface pH is a useful tool, and it can be used by management to both monitor and control the useful life of their system. What color is your system? What color is your system? And why should you consider Thioguard? Well, for one, Thioguard decreases all odor complaints, both organic and inorganic. In addition, as we've shown in this video, it decreases corrosion costs considerably. It also increases treatment capacity by 10 to 50%, reduces chemical consumption, reduces energy, and improves biosolids. This concludes a brief introduction to the benefits of Thioguard for corrosion. We invite you to visit our site at thioguard.com for further information. Thank you.